Through the years, General Motors has constantly sought new technology and new methods to implement and improve car and truck production. For our objective, now as always, is to deliver high-quality cars and trucks to our dealers and customers in the shortest time possible. To achieve this, we are constantly working on new ways to make cars better and more efficiently. And we are now working in a number of different ways to expedite the final delivery of these vehicles to our dealers and customers in the shortest possible time and in a market-ready condition. To assure product quality and reduce the possibility of transit damage, the final loading and shipment of the completed vehicles has always been a GM plant responsibility. Accordingly, the condition and completeness of every car and every truck is finally checked before it is released for loading. And if it is damaged or incomplete in any way, it is returned to the plant and repaired before being shipped. All railcar loading and tie-down operations are under the control of GM personnel and finally inspected by GM supervision before the cars leave the plant. By these means, we have always worked toward shipping cars that are in the best possible condition when they leave our plants. Yet, in the last few years, the extent and cost of damage sustained in transit by direct haul-away truck as well as by rail has risen alarmingly, and with a higher and higher frequency of complaints regarding late deliveries from our dealers and customers. These are serious and complex problems. So, to resolve them, in mid-1970, GM drew together experienced, knowledgeable transportation distribution personnel from the various car and assembly divisions into a central activity, now known as logistics operations. While their skills and specializations are varied, the goal of all of them is common: to move cars from the assembly plants to the dealers in the shortest possible time without damage. As a first step toward both of these objectives, the feasibility of virtually non-stop transcontinental rail shipment was explored, for it has been proved that cars on a moving train sustain very little damage, whereas those left unattended on a siding often present too tempting a target for those inclined toward mischief or vandalism. While numerous routes were considered, on March 20th of 1970, GM dispatched its first unit train from Chicago to Los Angeles, carrying cars and parts from 23 GM plants in Michigan. It's called a unit train because it travels as a unit to its destination and carries cargo for only one shipper, GM. Unlike conventional freights, it never stops to drop off a couple of cars at the many sidings along the way, although it must pause occasionally to change train crews. The first 35 cars carried more than $1 million worth of new GM cars to their owners in California, while the remainder carried parts and sub-assemblies for cars to be built on the West Coast. When it pulled into Los Angeles, it had crossed most of the continent virtually non-stop in just 62 hours, much faster than conventional freight. Since additional unit train tests proved equally successful, now there are 2 regularly scheduled GM unit trains daily to Los Angeles and San Francisco, and beginning in May of 1971, a 3rd daily unit train will carry cars and parts south to Atlanta. While cars on moving trains incur far less damage than those standing still, the practicality of side screens for our bi-levels and tri-levels is also under consideration, and more than 400 rail cars with various forms of side protection are now in use. Although side screens help, they offer little added protection against malicious destruction or parts theft. So, when GM developed its totally new Vega, it specifically designed the car for a totally new concept in rail shipment as well as production. When a Vega is completed and ready for shipment, it is loaded onto the side door of specially designed rail cars and secured in place. The doors are then closed, carrying the cars in an upright or vertipack position, fully enclosed and fully protected. As a result, these cars are impervious to any type of theft or damage while they are en route, so no matter how long the trip, even to the West Coast, the cars are in the same condition when they reach their destination, practically ready for delivery to the customer. Because of the overwhelming success of the fully enclosed vertipacks, GM is currently testing and evaluating containerized shipment for other vehicles. These units are called container packs, and each carries 3 cars, one above the other. For loading, the container packs are removed from the rail cars. Loading is fully automatic, from raising the vehicle into position to inserting it into the container. After each container is fully loaded and the vehicles are secured in place, the container packs are reloaded onto the rail car and locked down. Each rail car carries 4 containers, so the end result is 12 automobiles fully isolated from all outside hazards. Accordingly, this load of cars can move any distance through any weather and through any locality and still reach its destination in factory condition. During the entire period of the container pack shipping tests, not one vehicle was damaged in transit, and when more sophisticated car and container handling equipment is applied, the likelihood of any damage occurring during loading or unloading will be further reduced. Because of the success of these tests, more widespread use of containerized car shipments can be expected in the near future. In addition to working on new ways to protect cars in transit, GM Logistics now uses computers to trace the daily movement of the more than 11,000 rail cars that carry GM cars and trucks. We call it computerized rail car tracing, and its purpose is to expedite the rail transit time from our assembly plants to the 58 unloading ramps across the nation. Here's how the system works. These computers contain the complete details of every route from every assembly plant to every destination across the country, and they know how far a rail car should move along each route in 24 hours. Accordingly, as each car or truck is released for shipment at the assembly plant, its rail car number, route, carrier, destination, and so forth are recorded on the car shipper. And as each rail car is filled, the information from the car shippers is transferred to bills of lading. Then, this information is converted to punch tape for transmission via teletype to the computers in Detroit to record the start of trip information for each load of vehicles. By this means, every rail car loaded with GM cars and trucks in the United States is under constant surveillance from the moment the cars leave our assembly plants. For the rest of the first day, the progress and movement of these cars is up to the railroads. But at the end of each 24 hours, between midnight and 8 a.m., the position of each of the 11,000 GM rail cars across the country must be reported. The means of recording the position and number of each car may be the plain old eyeball method, or it may be something more sophisticated, such as this inside remote-controlled TV monitoring arrangement. At some of the larger yards, rail car position reporting is fully automated and computerized, as the rail car numbers are read by automatic scanners which feed directly into the railroad's car monitoring system. But regardless of the means used, be it complicated or be it simple, every day by 8 a.m., the position of each and every one of GM's 11,000 multi-levels has been reported to our computer in Detroit, and in less than an hour, this information is digested and analyzed. For those cars moving as specified, no action is required. But for those that have been sidetracked, misrouted, not reported, or delayed en route in any way, the computer produces an exceptions report that includes all known data regarding the car, its present position, due date, route, carrier, and so forth, and transmits this information ahead to the rail car's destination. Each morning, as soon as these exceptions reports are received, they are reviewed by the GM ramp manager, and for those cars requiring immediate action, calls are placed to the railroads to expedite their movement. Although the computerized railcar tracing system has been operational for a relatively short time, some potential improvements in rail delivery service are already apparent. In addition to expediting incoming rail shipments, the GM ramp managers oversee ramp conditions and the entire unloading ramp operation, for an equally important part of their job is to see that these cars are unloaded promptly, handled properly, and moved out to the dealers in the shortest possible time. This means regular inspection of the baying areas to check for handling damage and to make sure that certain cars aren't just left sitting, waiting patiently for delivery. So this also means he must work in close harmony with the trucking company, its drivers, its dispatchers, and its management to resolve any problems that may arise and still maintain the most efficient and equitable shipping schedules possible for all dealers within the area. While the work of GM's 32 ramp managers is expediting and improving our delivery to the dealers, there are still numerous complaints that the shipping time allowances from our plants to some dealers are inadequate. So to make any adjustments that may be necessary, GM is now collecting data on the actual shipping time required from all plants to all dealers for comparison with the current shipping allowances. To record the actual shipping date for each vehicle, the same start of trip information is utilized, but in this case, the individual vehicle identification numbers are transmitted to Detroit, where their shipping dates are recorded and retained in a memory bank. So long as the car remains on a train or on a haulaway company's truck, there is no further input to the computer until the cars are actually delivered and the haulaway truck returns to its yard with the completed delivery reports. Only when this occurs are the final delivery verifications sent to Detroit. By comparing these inputs, the actual delivery dates, to these inputs, the actual shipping dates, the computer will be able to determine the actual shipping time requirements to all dealers from all plants. After sufficient data are acquired, all necessary adjustments will be made in each dealer's shipping time allowances to assure equity. While there is still much to be done, a great deal has been accomplished in the relatively short time since GM Logistics Operations has been formed. For today, tests have been completed to provide added protection for cars in transit, and some containerized shipments are already a reality. And today, with computerized railcar expediting, 2 daily unit trains to the West Coast, and GM ramp managers at the 32 major railhead and distribution centers, the potential for substantial improvements in most assembly plant to dealer transportation times is already apparent. And in the near future, all transit time allowances will be reviewed and readjusted as necessary to reflect the actual transit times from all assembly plants to all dealers. These men know the transportation and distribution problems, and they are working to resolve them, for we all have the same objectives: to move GM cars and trucks from the assembly plants and on to our dealers and customers in the shortest time possible and in a market-ready condition. We know the problems, and we will resolve them.